Hello, my dear students. Welcome back to my channel. I am your mathematics guide, Rahul Kishore Nigam. As all of you are aware, that I have initiated a series on PYQs of CBSE Class 12 Mathematics, and I have taken chapter number first, Relations and Functions, of which I am discussing the PYQs. Today, I have taken two new questions. The first one has been from CBSE sample paper, and the second one is has been asked in 2025 CBSE board examination. So what is the first question? Here is the set which contains 1, 2, 3, 4 and R with the equivalence relation on A Cartesian product A defined by A comma B related to C comma D. If and only if A plus D is equal to B plus C, find the equivalence class of related to this ordered pair 1, 3. You know that equivalence relation if defined on any set, here is the set A, then it partitions the set in disjoint equivalence classes. It is the concept. So what we have to do, let us take for determining the equivalence class related to this ordered pair 1 comma 3, we will consider a general ordered pair. So let xy related to C comma D. And what is the punchline of the relation? The relation is if A comma B related to C comma D, if and only if A plus D is equal to B plus C. So in place of A there is X, in place of B there is Y. In place of here we will take 1 comma 3 because one we have to determine the equivalence class related to 1 comma 3. So here we will take 1 comma 3. So in place of C it is 1, in place of D it is 3. Apply this situation here. So we will use this sign because if and only if means necessary and sufficient conditions both are justified. The meaning of IFF is if and only if necessary and sufficient conditions. So we will use this sign here. So in this way we can write A plus D is equal to B plus C. In place of A there is X, in place of D there is 3, in place of B there is Y, and in place of C there is 1. So we will use it. What can be done here? So we will write it 3 minus 1 is equal to y minus x. In this way, y minus x is equal to. So we have gained this equation, y minus x is equal to, and this equation, this relation will play vital role in determining the equivalence class related to this ordered pair 1 comma 3. So let us see now this set 1, 2, 3, 4. So how to determine the equivalence class? We can take the alternate numbers. If we take 1, 3, the relation, this equation, the relation possessed by this equation is justified. So because if you subtract 1 from 3, you get to 4 minus 2 is also 2. So what is the equivalence class related to this ordered pair? It is this 1 comma 3, 2 comma 4. This is the answer of this question. Okay. Now the second question, to prove that f from n to n is defined as fx is equal to x plus b, a comma b belongs to n, is 1 1 but not onto. So for determining, for checking that whether this function is 1 1, so let the image in the codomain is the same. We can also take fx1 not equal to fx2 because for a function to be 1 1, distinct elements of the domain have distinct images in the codomain, or the same elements of the domain have the same images in the codomain. This is the concept of the 1 1 function. For this we will take the images are the same. If we take images of the same, images of x1 and x2 in the codomain are the same, then if respective pre-images are also same, then we can say that the function is 1 1. So what is the definition of this? We can write here ax1 plus b, here ax2 plus b. So in this way it will be ax1 is equal to ax2. If we divide by a, so we will simply get x1 is equal to x2. So this is 1 1. It is 1 1. It is justified. Now for onto, very simple. Let fx is equal to y. So we can write it ax plus b is equal to y, or in this way we can find the x. What is x? What is the pre-image x? What is pre-image x? It is y minus b. It is y minus b upon a. Okay. Here a comma b both are the natural number. and y and x are also the natural number, because domain and codomain both are the set of natural number, and natural number starts from 1. So for some we can say that y is always greater or equal to 1. Y is always greater or equal to 1. Y is always greater or equal to 1. Okay, so here if if y is any number greater or equal to 1, and b is also, y is any natural number and b is also a natural number, b is also a natural number. So if we subtract any natural number, if we subtract, for example, if we take any number, if we take y is equal to 3, y is equal to 3, and y is equal to 3, and b is equal to 1, and b is equal to 1, and a is equal to 4, a is equal to 4, then what is the situation here? X is equal to, 3 minus 1, 3 minus 1 by 4. X is equal to what? X is equal to 3 minus 1 by 4, that is 2 by 4, and that is 2 by 4, that is 1 by 2. Means the pre-image, of y, which is 3, in the domain will be 1 by 2, but 1 by 2 is the rational number. So but here is domain is the set of natural number, so we will not get the pre-image of y. Pre-image of y is equal to 3 in the domain if we have taken a and b certain different natural number. So it is clear that the pre-image of all the natural numbers of the of all the of all natural numbers of the codomain will not be available in the domain. That's why we cannot say that this function is onto. So this function is not onto. It is not onto, but it is 1 1. So we can justify this question in this way. So this is all about the solution of this question. Thank you very much.